Okay, so we look at these past questions for logarithms, right? We're going to start here with question one. It says log x plus 2 equals log x minus 4 plus log 3. Find the value of x. Okay, here in this type of question, they're asking you to find the value of x. So whenever you see a question in this format like this, okay, and you even see logarithms are adding each other here, you're going to apply the product rule of logarithms, which is this one here. Okay. What you are adding, okay, the values. Remember with logarithms, this b is the base. This m is the value. Okay. So the values, you're going to multiply them. Okay. So in the same way here, with this question here, these are the values here, x minus 4 and 3. Okay. So it becomes log x minus 4 multiplied by 3. Okay. Yes. So remember, you can only apply these rules when the logarithm has the same base. So if you see a logarithm just written like this, logarithm 3, always know that here the base is 10. Okay. So for here, this is base 10, and base 10. It's just that you won't write it. Okay. So you only apply these rules if the bases are the same. Okay, so we've applied the product rule, so we're multiplying the values. X minus 4 times 3. Okay, so you're going to say 3 times x, that is 3x. 3 times negative 4, that is negative 12 here. Okay, on the left hand side, you still leave it as log x plus 2. Once you reach this position here, where you have a log on the left hand side and the log on the right hand side, you cancel out the logs now. Okay, you cancel them out. So now we remain with x plus 2 equals 3x minus 12. Okay, and we go back to normal algebra. Group. So here, this is one to find the value of x. We have to group like terms. So this x is going to go over this side. It's positive, so it will become negative. That's why we have a negative x here. This negative 12 is going to go over the equal sign here and become positive. That's why you have a positive 12 here. Okay, so you have 2 plus 12 equals 3x minus x. Okay, 2 plus 12, that is 14. 3x minus x, that is 2x. Okay, so the value of x, you divide both sides by 2. X, you saw here, x will equal to 14 divided by 2, which gives you 7. Okay, so the value of x is 7. Any questions before we go to question 2? Okay, here we've got log x squared equals log x squared. Okay, again, they're trying to find the value of x. Okay, so what we can do here is this log x squared, we can bring it over this side here. So that our expression reads log x squared minus log x squared equals 0. All right, it equals 0. Then, once you reach this point, colleagues, whenever you see the value of a logarithm, okay, this x squared is the value of our logarithm. Okay, so this exponent attached to the value, we have to apply the power rule of logarithms. Okay, have you seen here? In our situation, we have log x squared. Okay. So this power, what happens is it comes in front of the logarithm. That's why you can see here k multiplied by log bm. So applying this power rule here, okay, this 2 is going to come in front of the logarithm. Okay, so we have log x squared minus 2 log x. Okay, yes. Then here we can factorize this. Okay, we can factorize this log x squared minus 2 log x. We can factorize this. Okay, just ask what is the common factor here. The common factor is log x. Okay, so you're going to say log x squared divided by log x, because the common factor, you're going to divide it by both terms. Okay, this common factor log x, we're going to divide it with this log x squared and this um, 2 log x. Okay, so you say log x squared divided by log x, you're going to get log x. Okay, that's why we put a log x here. Log x squared divided by log x, you get log x. Then 2 log x divided by log x, you cancel out the logarithms and you get, since it's negative here, so you get negative 2. Okay, 2 log x divided by log x, you get the 2 here. So that's why we've put it here, log x minus 2. Okay. Another way we could have done this, colleagues, okay, if the factorization is confusing you here, you can use substitution and you can say, okay, you can say let t equal log x, so that you have just letters here. Okay, so this log x squared will be t squared minus 2t, because log x is t. So you have 2t squared minus 2t, okay, equals 0. All right. That's the other way you can do it, using substitution. Okay. You say let, you can choose any let t, u, v, w. Okay. Then you factorize now. What is the common factor here? The common factor is t. So you're going to say t squared divided by t, that is t, minus 2t divided by t, that is t, okay, equals 0. Okay. Yes. So maybe, colleagues, I continue with this substitution method, then I show you the other method. Okay, because there are two ways you can do it. Okay, you can use the substitution or you just use the logarithms. Okay, yes. So okay, let me finish with the original one I started, then I also show you how to finish with the substitutions. So have you seen here log x open bracket log x minus 2 equals 0. So your two solutions will be log x equals 0 or log x minus 2 equals 0. Okay. Then now you want to find what is the value of x. Okay. So as I said, whenever I say logarithm, just written like that, no, it's written to base 10. Okay. So basically we're saying log base 10 x equals 0. Okay, then this other side here, this negative 2 will go over the equal sign. So it's log base 10 x equals 2. Okay. So I want you to find the value of x. So in order to get the value of x, you just say, because remember, a logarithm is how many times you multiply a number by itself to get a certain value. Okay. Mhm. Or you can think of it like this. If you raise 10 to the power 0, you are going to get x. Okay. So x equals 10 to the power 0. Okay. Even here, log base 10, x equals 2. You just say, okay, to get the value of x, you can just say, you can raise 10 to the power 2 in order to get this x. So x equals 10 to the power 2. Okay. Then 10 to the power 0 is 1. So one solution is x equals 1. Or 10 to the power 2 is 100. So x equals 100. Okay. That's if you don't use the substitution method. The way we've started here, you use this method to find the value of x. All right. Now, if we used the substitution method, okay, what we say here, with the substitution method, here we have t multiplied by t minus 2 equals 0. So you're going to say t equals 0, or, excuse me, t minus 2 equals 0. And that says t equals 2. Once you reach this point, remember you said t equals log x. So you substitute back. So you're going to say log x equals 0. And this side where t equals 2, you're going to say again log x equals 2. Then remember this is raised to the base of 10. And you do the same thing. To get x, you need to raise 10 to the power 0. Okay. And 10 to the power 0 is 1. Also here, to get x, you raise 10 to the power 2, and x equals 100. Okay. That is how you solve this question. You can either use substitution or that's the way the logarithms are. Uh-huh. Oh, to redo it from scratch, time, time, time. But let me just give a quick recap because uh, I want, yes, I want to finish as much. Yes. So whenever you see such a question like this one here, as you see here, log x squared equals log x squared. What we just did, because we want to find the value of x. So you bring the terms together. Okay. These questions, as I said, you usually, if you see such a question like this, where two logarithms are just equating to each other like this, most of the times it's going to involve some form of substitution, or there will be a quadratic equation somehow, somewhere. Okay. So, madam, we just brought the x's together. Okay. Once you bring, I mean, the logarithms together. Once you bring the logarithms together, it looks like a quadratic equation. Okay. The type of quadratic equation which you can solve by factorization. Okay. But as I would advise, just watch the rewatch the video. Okay, madam. Or maybe once I'm done with all the questions here, when we're doing practice questions, we'll review that one. Okay, this one was, you saw this one in your assignment, but let me just redo it again. Okay, question 3 here. Okay, 2 natural log of x minus the natural log of x plus 1 equals 0. Find the value of x. Okay, all these questions is find x. All right. So here, colleagues, with this question, since there is a 2 in front of the logarithm, so we need to apply the power rule. Okay, here, since we have a 2 in front of the logarithm, so this 2 is going to become a power to the value. Okay, that so our value in this case is x. Okay, so you bring this 2 and attach it to the x, so that you have natural log of x squared, okay, minus the natural log of x plus 1. So the reason why we did that, colleagues, is because we're about to apply another law of logarithms, which is the quotient rule. Okay, so we couldn't apply the quotient rule with these 2 in front here. That's why we applied first the power rule, so that this 2 gets attached to the value. Okay, so that now we can apply the quotient rule. The quotient rule is always applied when you are subtracting logarithms. Okay, here's the quotient rule. Okay, log bm minus log bn equals log bm over n. So you are dividing the values with the quotient rule. Okay, when you hear me say the word values, I'm meaning this m and n here. Okay, so you're going to divide the values. That's why it becomes x squared over x plus 1 equals 0. Okay. So once we reach this point, all right, here, we're going to now use one property of logarithms here. Okay. The natural log of 1 equals 0. Okay. The natural log of 1 equals 0. Okay. So any value, because here in this case, our value is x plus 1, x squared over x plus 1. So the natural log, so in this case here, if the natural log of x squared over x plus 1 equals 0, then we can assume that x squared over x plus 1 equals 1. Okay. We can assume that due to this property of logarithms, the natural log of 1 is 0. So in this case here, we're saying the natural log of this expression here, this value, is 0. So we're going to say that then, therefore, x squared over x plus 1 equals 1. Okay, which is also written down here. Since the natural log of a equals 0, and a is supposed to be equal to 1. That's what we have done here. We're assuming that this value of ours, x squared over x plus 1, since its natural log is equal to 0, so this expression should equal to 1. That's what we've done here. Any questions, colleagues, before I move further? Okay. So x squared over x plus 1 equals 1, and you're trying to solve for x. So you cross multiply. Okay. So you have x squared equals 1 times x plus 1 just gives you x plus 1. Okay. Then you can now form a quadratic equation. Basically, you take this x this side, this one this side. Okay? So that you have x squared minus x minus 1 equals 0. Okay? So since you can't solve this one by factorization, you use the quadratic formula. Okay. Before you use the quadratic formula, determine what is your a, the coefficient of x squared. Basically, the number in front of x squared, it's 1. B, the coefficient of x, the number in front of x is negative 1. And C, the number without a letter is negative 1. So the quadratic formula plus or minus b, oh, negative b plus or minus negative b plus or minus in the square root of b squared minus 4a times c. 4a 4ac over 2a. Okay. So you're going to say negative b is negative 1. So it's a negative 1 plus or minus negative 1 squared minus open brackets 4 times 1 times negative 1. Okay, over 2 times 1. Then the expression simplifies to this. Okay, negative and negative make positive. That's why we have a positive 1 here. Negative 1 squared. That's why we have a positive 1 here. 4 times 1 times negative 1. That gives you negative 4. Okay, you get negative 4 here. Okay, and then this negative and this negative make positive. That's why we have a plus 4 there. Okay, yes. So now with natural logs, you're not supposed to have a negative answer. Okay, because remember with quadratic equations, you have two solutions, and one can be negative and the other one can be positive. So here, when we do this, x equals 1 plus or minus the square root of 5. Remember, you separate them. It becomes 1 plus square root of 5 over 2, or 1 minus the square root of 5 over 2. Okay. Now we'll ignore this solution here because it will give us a negative value. Okay, and natural logs, you can't have negative values of x. Okay, so you're going to just focus on this one here. Okay, and so the square root of 5, of course, we'll finish this question. Square root of 5 is 2.23. 1 plus the square root of 5 over 2. Square root of 5 is 2.23 divided by 2. 2.23 plus 1, 3.23. 3.23 divided by 2, 1.61. Okay, so you just have one value of x, which is 1.61. Yes. Any questions so far? Okay, then we've also got this other question. Okay. Solve the equation log square root of x equals the square root of log x, right? So here, first things first, you want to get rid of this root sign here. So how do you get rid of that root sign? This becomes log x to the power half here, okay? Laws of indices. Remember, with a fractional index, you get this, okay? This law from indices, a to the power m over n equals the root of n, a to the power m, okay? That's the same thing that we've done here. Okay, so you're going to say log x to the power half equals square root of log x, okay? After you do this, the next step, this power, okay, we're going to apply the power rule of logarithms here, which is here, okay? The power comes in front of the logarithm, okay? The power comes in front of the logarithm. That's why you have half log x equals the square root of log x, okay? Yes. Then, as I said, whenever you see this type of equations, just know some. So you can use substitution method to make life easy. Okay, so you can say let y equal log x, meaning here this half log x becomes half y. This square root of log x becomes the square root of y. Okay, then we simplify. We want to get rid of this root. Okay, so we're going to square it, meaning also this side we're going to square it. Colleagues, take note. If I wanted earlier on, even here, we would have squared this. Okay, but I just wanted to do it in a simple step-by-step process. Okay. Mhm. So when you square this y, the square root of y, when you square it, the square root comes out. Okay. Then here, okay, because this half y is the same as y over 2. Y over 2 to the power 2. Okay. And remember, it's going to become y squared over 2 squared. That's why we're getting y squared over 4. Okay, here. Okay, this can be written as y squared over 4. Okay, y squared over 4 equals y. Then you cross multiply. Y squared here, 4 times y, get 4y there. Again, another quadratic equation. You bring this 4y over here. You have y squared minus 4y equals 0. The common factor, it is y. So this common factor, you divide it by y squared and you divide it by 4y. Y squared divided by y, you get y. 4y divided by y, you get 4. Okay, or you can say negative 4y divided by y, you get negative 4. Okay, either way, you get the same result. Then, this is also a quadratic equation, okay, colleagues? This is also a quadratic equation. So you're going to have two solutions: y equals 0 or y equals 4. Then you substitute back. Remember, I said let y equals log x. I could have also used t. Okay, I could have used t any let. So uh, log x equals 0, and here log x equals 4. This is base 10 is 10. Okay. So if you raise 10 to the power 0, so x equals 10 to the power 0. Okay. Or if you multiply 10 by itself 0 times, even if you raise 10 to the power 4, so you say x equals, or if you multiply 10 by itself 4 times, okay, we're going to get the values of x. Okay, so if we raise 10 to the power 0, you can see 10 to the power 0 is 1, so x equals 1. Here, 10 to the power 4, 1, 2, 3, 10,000. So x equals 10,000. Yes, colleagues.